And then we classified and analyzed the data. And this is a figure indicating the distribution of dose rates, the dose measured every 1 hour for 12 Japanese schools and 5 European areas in the form of box and whisker plot. The vertical axis indicates the dose rate in a logarithmic scale. The unit is microsievert per hour. The red bar in the box shows the median, and the whisker is 1.5 times as long as the box is, and the values higher than it were indicated as outliers with cross marks. The outliers were almost 1.5% of the entire samples. As you can see, the distribution of dose rate and outliers were almost equal in all areas. From these results, paying attention to median, the distribution of median is almost equivalent inside and outside of Fukushima prefectures and in overseas areas, as you can see. And outliers were similarly detected in all areas, but electromagnetic waves or noises can have influence on them, so we need to figure out the cause particularly. Thus far, I explained the distribution of dose rate, but when we discussed the risk of radiation to the human body, the annual individual dose is more useful. So, for each participant, we integrated the hourly dose over the 2-week measurement period and converted it to a yearly value. This figure shows the distribution of estimated annual individual doses in the form of a box and whisker plot. The vertical axis indicates the annual personal dose, and the unit is millisievert per year. Though a scatter occurred among the schools and the areas, the distribution of individual doses are almost equal inside and outside of Fukushima prefecture and European areas. I put them together in this graph. There is a difference in the range of the distribution of individual doses, but the exposure dose is almost equivalent in 5 regions. Focusing on the median, the distribution of it is almost equal. And we can say that the dose of Fukushima is almost equal to the natural radiation in other places. So we discussed the reason why personal doses in Fukushima are not much different from other places despite the soil contamination. So these bars indicate estimated natural background from thorium, uranium, and potassium-40 concentration in soil samples. And these boxes indicate the personal dose distribution, including both of natural radiation and radiation from radiocesium. According to this graph, it is considered that actually there is an influence of radiocesium, but because of the lower natural background in Fukushima, the total dose are not much different from other parts of Japan. And lastly, we attempted to analyze the main cause of external exposure as a future work. By making use of the D-shuttle feature that it can measure the dose every 1 hour, we checked the data against the journal and analyzed the main cause of external exposure, where we are exposed to radiation the most. We are going to make use of this feature to do risk management at places where people need to deal with radiation exposure. These are the examples. We focused on the dose at school and at home where students stay the longest, and made histograms. These are the histograms showing the distribution of dose rate, and these three graphs are these graphs are histograms of 3 schools whose distribution of those rates were characteristic. The horizontal axis indicates the dose rate, and the vertical axis indicates the number of the samples. The color green shows the distribution of school dose, and yellow does home dose. At school 12, which is our school, home dose is higher than school dose. This is because school building is made of reinforced concrete and its shielding effect is very high, while wooden houses are easily influenced by outdoor radiation. In contrast, at school 5, which is in Gifu Prefecture, school dose is higher than home dose. This is because of the radioactive substances in the school building materials. And at school 3, which is in Nara Prefecture, the distribution of home dose and the school dose is almost equal, and the entire dose is low. Thus, by checking the data against the journal, we can analyze where we are exposed much. So it is considered that the measurement of individual doses with the use of activity journal can be a powerful tool for risk communication for people living in contaminated areas. So this is our conclusion. We conducted an investigation to measure and compare the individual doses inside and outside of Fukushima Prefecture. And we got to know, at the moment, high school students in Fukushima do not suffer from significantly higher levels of radiation.
So that's the conclusion, and let me give you some background information. So we started to do this project in the summer of 2014. So we distributed the D shuttle, this, first to Japanese high schools, the 12 high schools that you already saw on the map. And in the summer of 2014, the students, the co-authors, came to Fukushima and had a workshop, trying to analyze and understand the situation. And this is Haruka working hard, analyzing the data. And on the last day, we had a meeting reviewing the result, and this was the summer of 2014. And later on, we sent these dosimeters to Europe, to France and Poland and to Belarus. And in December 2014, they came back. They came back to Fukushima High School. And when we opened the box, and then this is when we started to examine the D shuttle. In the summer of 2015, last summer, French co-authors, the French high school students, came to Fukushima, like this one. Okay. When they came, already while they were in France, they put on this D shuttle, and then came to Fukushima. So this shows a graph of the personal dose per hour. This is 0.2 microsievert per hour, okay? And this is while they were in Paris. This is the overlay of the graph of 8 French students, and 4 teachers and experts. So you see the first peak here, that's this peak. This is when they had to undo this D shuttle and put on the tray for safety inspection at the Charles-de-Gaulle airport. So this was X-rayed. And then this huge peak here is during their flight. Okay, then they came to Tokyo. On the second day in Tokyo, we all got invited to the French embassy for a reception. And again, we had to undo, and then this had to go through the security gate. And that's this peak. On the third day, we all got on the bus and drove on the coastline on Route 6 to Iwaki and to Fukushima. And then we went to Tomioka Station. How many of you know where Tomioka is? That's 10 kilometers south of Fukushima Daiichi, and it is within the restricted zone. And we went there because French students wanted to see the effect of tsunami, not the radiation, but the effect of tsunami. And this picture was taken by me on that day in front of the Tomioka Station. So that's this peak. Okay, so it is higher. And after that, we went to Miyakoji. How many of you know where Miyakoji is? Raise your hand. Okay, fine. So Miyakoji is a town, this district within the 20-kilometer zone. And the government lifted the evacuation order in April 2014. And people returned and started to live there. And we visited the farmers in Miyakoji. And this picture was taken on that day. Okay, so the farmers sitting here, okay, entertained us with the beautiful tomatoes and cucumbers and watermelon and so on. Okay, and as you can see, the radiation level isn't high within the 20-kilometer zone, in Miyakoji at least. And on the last day, we went to Kunimi, which is famous for peaches. So we went there and talked to the farmers, and then on the way back, we picked the peaches and went back to Fukushima High School and measured the peaches, of course, together. So as you can see, not much difference. We carried the same dosimeter from Paris to Tokyo and various parts of Fukushima. And as you can see, the external dose, not much personal dose, and not much different between Paris, Tokyo, and Fukushima, at least in the region where people live, where the high school students live. So that's the conclusion. So thank you very much.
Thank you both. So we will go to the Q&A. When you raise your hands, please give your name and your your name and your media. Thank you.
Oh, by the way, this brochure contains most of the slides that Haruka showed with the transcript. And this was prepared after when we went to Milan, the food expo, and we attended this food safety conference, and she gave a presentation, essentially the same presentation as you've just heard. So this contains the information, and also my presentation in Milan. It's also included in this brochure.
Right. Do you have any questions?
Thank you very much for the very interesting report. It was very interesting. I'm freelancer of the Foreign Press Heroes also. I would just like to ask both of you about the comment on the Professor Tsuda's paper, because this Professor Tsuda made a presentation here a month or 2 months ago, and gave some impact to the. But it is, I think, quite a controversial paper. So I'd like to ask your comments on that.
Well, she doesn't take this question. You understand, right? So maybe it's better that I try to answer this question. I'm not an expert on this subject. But you may be aware that on this journal, where Tsuda's group published this somewhat controversial paper, there appeared 7 letters online. This one, and these ones. That you can go to this site and have a look. And all these letters from world experts, each one is about 400 words, so that's not a very long letter, but each one point out that there are flaws in Tsuda's argument and so on, and you can read and judge yourself.
Any other questions?
Two very brief questions. First of all, I'm James Cole from the University of Tsukuba, and I am a particle physicist, by the way. So one thing I would like to ask about the radiation monitoring. I understand that these badges mainly measure cesium. Is that true?
No. No.
All right.
This contains, well, please allow me to be a bit technical. So this is an electronic dosimeter, which contains, which uses silicon.
Oh.
So silicon is in your camera, okay, the digital camera, okay, right. So it is sensitive to gamma rays within a range of some 50 kilo electron volt up to about 1 MeV. So this picks up the gamma rays from natural sources like the potassium-40, which emits a gamma ray at 1.4 MeV, and the thorium and uranium, that's the long-living isotopes which alpha decay and then subsequently emit gamma rays. These are the sources of natural background that every one of you receive. Plus, of course, the cesium gamma ray, which is at 0.6 MeV. So this measures everything. All these gamma ray sources, natural plus man-made, as although just explained to you.
One thing that I do wonder about in some of these measurements, though, that the beta particles from cesium decay do have a range of about 1 meter or so. And so if you're standing above 1 meter, then you're not going to see a lot of that. So if you're a baby crawling on the soil, you would get one measurement, whereas if you're an adult and the badge is up here, you would get another measurement. And then the other thing I also wonder, I don't doubt that the data of this study has been properly taken, but one thing I wonder now that, well,
One question at a time, okay?
All right, yes, all right.
So
yes.
would you answer this beta ray question?
Okay. We measured the exposure dose of high school students in this investigation. So I hope we will send these shuttles to smaller kids and measure the dose and compare the individual dose.
Well,
in the
the beta rate, as you are a particle physicist, you know very well that the beta ray range is very short, so that it doesn't affect, that it doesn't contribute to the effective dose at all. It only
Except for babies on the ground.
but that's also the skin irradiation, and it doesn't contribute to the effective dose much. So when you live in Fukushima, and also remember that potassium-40 also emits beta rays, and the decay products, the uranium, thorium, also emit beta rays, and they are all natural sources which exist on everywhere in the world.
All right, so one final quick question then. Since this survey was done several years after the event, I should say, well, now it's 2016, but nearly 4 years after the event, yes.
Yeah.
5 years, now it's 5 years, 2011 to 2016, nearly 5 years.
So this was done in 2014.
2000, so 3
Yeah,
years,
3 years,
after
yes.
the event.
Yeah.
3 years after the event. So the iodine has been missed. And so we do hear reports, I know that you can't go back in time and measure that, but we do hear reports about children with abnormal number of cysts on their thyroid glands. And I wonder how this would have any correlation. I guess this sort of radiation that you are measuring would not have any effect on this, but I'm just wondering if you could comment on this.
Would you? Well, the correlation between the deposition of cesium on the ground, which you see here, and the possible intake of iodine-131 in early phase. I remember the iodine-131 has a half-life of only 8 days.
Yes, it decayed pretty quickly.
Yeah,
yes.
right. Whether the iodine distribution is the same as what you see on this map, it is not clear and probably maybe slightly different, because what you see here is the effect of the dispersion of cesium plus the effect of rain, which so the rainfall brought down the radioactive cesium from floating in the air together with other particles.
All the way to Tokyo, yes.
Yeah, and then deposited the cesium on the ground. So our study essentially has no correlation with and does not contribute to understanding the early possible exposure of iodine to people living in Fukushima.
All right, thank you very much.
Yes. Are you a working press? A working press. Can I have the working press first? Oh, okay. So.
Hi, Eric Slavin with Stars and Stripes. Do you feel like you've definitively answered a question here regarding the type of radiation you're studying in these areas, that it is not, in fact, an issue at these high schools, or do you think that there are other variables that could affect in the future whether or not this does become a problem again in these areas and that more study might be needed in order to determine safety?
Would you like to answer? Okay. I discussed in my presentation, which is shown here, that the effect of internal exposures in Fukushima is very much less than what we initially feared. And right now, it is almost no problem. As long as you are eating the food stuff from market, marketed food stuff, which was not the case at Chernobyl in the case of Chernobyl accident, when the report shows that the dose of internal exposure dose increased after 5 to 10 years. It decreased first and then it increased again after 5 to 10 years. So people were very cautious, and we were also very cautious initially, so that thinking that we should not let that happen. So that the food are under control right now. You know that the rice bags, last year's rice bags, more than 10 million of them were examined, and none exceeded 100 becquerel per kilogram limit.
Bullshit level, DEFCON 5.
Last year's rice bags, more than 10 million of them were examined, and none exceeded 100 becquerel per kilogram limit.
That was bullshit.
So, so in the future, I don't think that in Fukushima the internal exposure effect will go up again like it did. in the case of Chernobyl accident. The external exposures are rather predictable, right? At decay, and then there is the effect of weathering. And of course, our study didn't cover the region where people are not living. I mean, this exclusion zone, that's the restricted zone, which is indicated by this white contour. This inside of that white contour is not included. But the government will be lifting the evacuation order gradually, and the people start to live in there. There may be some surprises where people get exposed to additional external and some internal exposure, unless people are cautious about what they eat and so on. So as long as people live in the zone outside, I think the people living in Fukushima understand very well the potential risks or the lack of potential risks from food exposure, and also the effect of additional external exposure, which is becoming low. Of course, there is some effect, but that effect is, as you have heard Haruka's presentation, is within the range of external exposures in other parts of Japan or elsewhere in the world. So, yeah, we have to keep measuring, and we have to keep informing people. But I would be surprised that there will be people exposed to, say, 20 millisievert per year of radiation in the future. I don't think that will ever happen.
Thank you. My name is Tim Horniak. I'm a freelance journalist here at the FCCJ. A very interesting way that you formulated this study by recruiting high school students. Very unusual. How did this come about? Who had the initial idea to include students in this? Or how did you propose to do the study? If you were the ones who had the idea at first, what inspired you to get involved, and to how did you get this idea to use this D-shuttle personal dosimeter and go to Europe first and then to back to Fukushima? Could you tell us how that came about, please?
Okay.
Thank you.
You answer.
And so I conducted this investigation as a member of a super science club at my high school. So, and I didn't know about radiation in detail at the time when we measured and compared the dose. So I was studying the radiation and conducting the investigation, and so so as a citizen of Fukushima, I want to know how high my the exposure dose is, and I want to compare those with the people living in other places. So, so I participated in this study.
Well, it was the students who triggered this. Of course, I provided the D-shuttle and advised them that this may be an interesting device to use. But the motivation came from the students living in Fukushima. That's definite, and it is also described in the paper. The paper says that this study was motivated by the high school students who wanted to understand better their current exposure situation. Does that answer your question?
Yes, right.
Hello, my name is Joël Legendre from RTL Radio from France and BFM TV of France. yeah, it's very peculiar, your experiences. And has it been validated by any scientific authority, your report here? And have you had some help from your friend of CERN, the European Nuclear Research Center? And the last question, if they were really risk, would you tell us that they are really risk for the children?
Okay, well, it's, I work at CERN. I am a physicist commuting to Geneva every month, almost. And I have a group at CERN in Geneva where I do my own research, which is about antimatter. But for this particular work, I used my own experience as a physicist and also a person knowledgeable about radiation measurement, but I didn't get much information from CERN. But this, of course, this paper, the authors include experts from France, I keep forgetting the name of this institute. That's, for instance, number 32. That's CEPN. Does that mean anything to you? Page 51. The third page. Also, CEPN, that's France. That's the professional, and also there is a contribution from IRSN. So they are participated in this study, but they are just one of two of them came. What was the other question?
So about any scientific authority validating, you answered that no.
Well, this was validated. Because this is the Journal of Radiological Protection. This is a professional journal.
It's published.
Published, yes.
Not confirmed.
No, yeah, published, but this is refereed, and referee report came, and what did you do with the referee report? Sadoko-no, yeah, I gave you the referee report, and you wrote the reply, right? Yeah. So yeah, there was a communication between us and the referees, and in the end, it was published. So that if somebody wants to, the data is available, and this device is also available. So if somebody wants to either confirm or discredit our work, you're welcome to do so and publish your own paper. That's always possible. So this is refereed and is published.
Anybody else questions?
Hi, thank you very much. I'm an editor of Philosophy magazine for high school students, and I'd like to ask Onodera-san 2 questions. I'm amazed to see the word this communication in this conclusion, last part, and you said that the measurement of individual dose rates together with the use of activity journals is a powerful tool for understanding the cause of external exposure, and it can be useful and clearly understandable tool for risk communication for people living in contaminated areas. And so I was amazed to see the word risk communication. So could you give me some concrete example for this word in the ordinary sense? And can I ask you one more question? And how did the result of this study change your life? Thank you.
Okay. So first, I'll answer your first question. Risk communication is なんて言ったらいいかな。
The use of the shuttle, how is this useful to communicate the risk to people?
And so we can know where we are exposed much by using by the using of the personal dosimeter and activity journal, and so we can tell people living in contaminated areas to you are exposed somewhere or anywhere. なんていうかな. So other people can take measure against the exposure, or the people can improve their living. So I think this is risk communication.
So yeah, we can if somebody's dosimeter shows this, and then you find a peak, and then we ask them, we ask this person, where were you? And then this person can understand, aha, that's when I went that place and so on. And that will help people to better understand their present situation. That's what she wants to say. Okay, go on.
So,
この結果がスタディが何を書いたか。
So, through this investigation, I understood how important it is to evaluate the risk based on the objective or scientific facts. So I'd like to keep this, to keep it in mind and to inform people of the importance of the judge basing our judgment on objective facts.
I wonder if we could just take a quick sidetrack from this study to your own research at CERN you were talking about. If you wouldn't mind, just briefly telling us the focus of your research. I understand antimatter is part of your research.
Yes.
Are you also considering dark matter? And if so, what do you believe dark matter may be composed of at this stage?
Okay, well, I'm interested also in dark matter, but my present research at CERN does not address this question directly. What we are doing right now is to measure precisely the masses of proton and antiproton, and should there be even a tiniest difference, that would be a Nobel Prize-winning result. And so we are trying to measure precisely the masses of proton and antiproton. And what we think what I think about the dark matter, I don't know. Because I am at CERN, my thinking is probably slightly biased, because people at CERN hope that LHC someday, not in the far future, can discover a candidate particle for dark matter, that is the lightest supersymmetric particle. Whether that happens or not, we don't know yet. That if there is indeed a lightest supersymmetric particle within the range of the LHC energy, then it should show up within a few days from few years from now. So that's what we are hoping to discover.
I am former Japanese ambassador to Switzerland, Murata. I highly appreciate your precious work because it is necessary to reassure people living in Fukushima. On the other hand, I would like to point out new development. Former Prime Minister Hatoyama, former Prime Minister Kan both just recently clearly denied that Fukushima is under control. And now there is an important international impact. And I would like to refer to your optimism as to the future development, because nothing has been solved in Fukushima. Nobody knows whereabouts, how is the situation about the molten fuel rods underground, and anything could happen. Criticality, hydrogen explosion, or steam explosion. Under such circumstances, what is needed is the sense of crisis. Actually, I think what Japan faces, the sense is the crisis of Japan as a nation, not the crisis of the management of electric companies. So I would like to ask, as if it is permitted, to be optimistic about future development.
That's not a question, right? That's just a comment. Yeah.
But can you, he's also asking a question. I think that's, is it possible, do you see any possibility for Fukushima in the future?
Well, it is quite unfortunate that that particular nuclear power plant carries the name Fukushima. When you say Fukushima, you meant Fukushima Daiichi nuclear power plant. It doesn't mean Fukushima High School or Fukushima Prefecture or Fukushima City. So use the word carefully when you say Fukushima. Be explicit. Is it Fukushima nuclear power plant, Daiichi nuclear power plant, or Fukushima Prefecture, or Fukushima City? Please.
My name is Asby Brown. I'm a volunteer with the Citizens Radiation Monitoring Group, SAFECAST. And I've been following Dr. Hayano's work for a long time, and I'm well aware of this project from before. I have two questions. One is, these kind of comparisons are very important for helping people understand what's normal, and our judgment about that needs to be based on these kind of comparisons. One, for Dr. Hayano, do you think it is possible or likely to do a similar study involving internal contamination, comparing people around the world as well? And then for Ms. Onodera, it's very impressive work. I also actually want to apologize for my generation's sake for dumping this problem on your generation. And I've met lots of young people in Fukushima who, like you, are not letting it give them a sense of defeat, but are learning how to measure and learning how to take control. What do you think is the best way to move forward in the future for helping people understand their doses, their risks, and how to live in Fukushima? You personally.
Can you go first? Yes.
Thank
Yeah.
you. So, yeah. So, there is various opinion among us high school students participating in our investigation. But one thing we do share is the importance of basing our judgment of on objective facts, as I said in former question. So I think all people can take away such we adopt such such a way as we adopted in this investigation. Everyone can evaluate the risk and take measures properly. So basing to make a judgment based on a scientific fact is the best way of improve the situation, I think.
Okay, so back to the first question, a comparison of internal exposures worldwide. That's an interesting but probably a very meaningless question because we eat radioactivity every day, like potassium-40. Every one of us has about 4,000 becquerels of potassium-40. And also we have carbon-14. And so when we use our whole body counter, which we use to assess the internal exposures of Fukushima people, we see right now only the peak of potassium-40. Okay, so every one of you is emitting potassium-40 gamma ray, about 200 gamma rays coming out of your body every second. So when we do this measurement here in Tokyo or elsewhere, or in Paris or in Moscow, all we see probably will be just potassium-40 peak. And that is almost constant because the amount of potassium, natural potassium, is controlled. If you eat too much potassium, then the body doesn't need the excess amount of potassium, so that the body will just emit the potassium-40 in the urine. So we don't see, even if we were to compare, I don't think we learn nothing. Maybe it is the amount of potassium-40 is proportional to the amount of muscle. So you will be just measuring the amount of muscle across all the populations in other parts of the world. So I didn't quite understand why you proposed to do this.
To help people understand what's normal and how that
Okay, all right, okay. In that sense, we can measure, and then tell the people, oh, okay, we all have potassium-40 and nothing else. Yeah, we could do this. Yes.
On this.
As you know, during the decommissioning of the Fukushima Daiichi nuclear power plant, one of the most difficult tasks will be dealing with the melted down fuel. Mm-hmm. And this is not something that people really know how to handle to a great extent, and various solutions are being proposed. First of all, removing the debris with robots and other things like that. How do you think it's going to go, and what do you think is the best shot of, or the best way to proceed with this very, very difficult task, if you had to speculate?
Is this for me or for Onodera? No, I'm asking, you're asking this question to a wrong couple. We are not the best people to answer your question, but yeah. Well, you know, this attempt of muon tomography. Okay, so the resolution is not that high yet, and takes a long time, about a month of exposure. But that's the first hint. That gives you the first hint of the whereabouts of melted down fuel. Because other attempts, like sending a robot or inserting the fiber camera and so on, so far have all failed, and the only data that we have, that they have about the whereabouts of melted down fuel is from the muon. That's do you know about this muon tomography? That's quite interesting. If you don't, Google and have a look. That's quite interesting. There's this naturally occurring muon, that's the cosmic ray, which penetrates this hand like this. 1 particle per second or so go through this. And so they use this to make a picture of Fukushima Daiichi unit number 1, I think, to look inside and whether the fuel rod is still in the pressure vessel or there isn't. And their answer is, which was made public last year, I think, is that there doesn't seem to be the fuel rod in the pressure vessel of unit number 1. But then what? is a difficult question, and people don't know. We don't know. There are 7,000 people working every day at Fukushima Daiichi site, and this is going to be a very long work. Actually, to understand, to control the water, and then to understand what's inside, and we don't know. Will take. Well, they say the project will take 40 years, but how long it will actually take, we don't know, because we don't know what's inside, and opening and actually taking out the debris is very hard, and new developments are necessary, and 40 years. You will be retired, okay? I'll be dead. So it is when these young generations, the young people are needed. Not she maybe, but this generation will be needed to control and understand what actually happened at Fukushima Daiichi. So this is why we have to train and work together with the young generation. You agree?
I do. Just one follow-up question for Onodera-san. Did this inspire you to pursue any career in particular when you graduate from high school?
Good question.
I think I want to be a scientist of molecular biology. So I will not relate to radiation as well.
Liaison German Press Agency, DPA. One question. The radiation is, according to your study, very low. It's almost the same as in Paris or other parts of. What's the reason for that? Is that because the decontamination work by the government has been so successful? And would you say it's done now? We don't need to continue decontaminating the area? Everyone can come back. Would you declare Fukushima now as a safe place to live? What's your?
You go first.
Yeah. Actually, we didn't measure the dose of people living in a contaminated area in this investigation. So.
You mean the restricted area?
Yeah. So. We can't say the whole Fukushima is safe, but I hope we will send the shuttles to a contaminated area and help to do risk management for people living there in the future.
Well, this gives you an answer, part of the answer to your question. It is the effect of cesium is definitely there, still. But fortunately, after 4 years, or five close now to 5 years, the radiation level has become low. So far, mostly due to the decay of cesium-134, which has a half-life of 2 years. Okay, that means that the cesium-134 contribution, which was dominant in the first year. In a very early phase, of course, it was iodine and other short-lived nuclide. But in the first year or first 2 years or so, cesium-134 contribution to the external dose was a dominant contribution. And that has decayed. Okay, so that's decontamination, I mean the cleaning the houses and so on, must have contributed to some extent, but the largest contributor was the decay of cesium-134. The remaining contribution comes from cesium-137, which has a half-life of 30 years. So this will stay. This contribution at the additional contribution from cesium-137 will stay for many more years. But fortunately, as you see here, because the natural background from potassium and thorium and uranium was low before in Fukushima, when you add even with the added contribution from cesium, the total stays similar to other places. So we do not declare that Fukushima, the whole region of Fukushima, is okay. Of course, we didn't, as Haruka already explained. Our paper doesn't say anything about the region within the 20-kilometer zone or in Iitate village, where people are still not allowed to live. But in other parts of Fukushima, I would say that the daily, if you are conducting normal life, like the high school students who come to school and then do some extracurricular activities, outdoor and so on, then it is like in other places. The Fukushima is not particularly unsafe. That's our message.
Can we take the last question? Since
yeah.
yes. Okay, so we have the last question.
Thank you, Hirosasu again. I very much respect your scientific and objective approach to this object. But there are some people very clearly anti-nuclear and very much strongly appealing for the stop any nuclear disease. And they are quite vocal and active. Are you receiving any personal threat or uncomfortable sort of exercises by this group, or are you free from that kind of thing?
That's a rather personal question. I'd like to refrain from answering your question. But I note. Yes, that's it.
All right. So thank you very much for coming to the conference. And if you have any further question, maybe you can approach it privately to the Professor Hayano and Odatina. So thank you very much.
Thank you very much.
The events at Fukushima reinforced that any nuclear accident with public health and safety or environmental consequences of that magnitude is inherently unacceptable. While we focused on the radiological consequences of this event, I believe we cannot ignore the large social and economic consequences such an event poses to any country with a nuclear facility that deals with such a crisis. In Japan, more than 90,000 people remain displaced from their homes and land, with some having little prospect for a return to their previous lifestyle in the foreseeable future. While not easy to characterize, these are significant hardships on these people and they are inherently unacceptable. So as we look to the future, and we look in a proactive way, we ultimately will have to address the issue of how we deal with nuclear events that lead to significant land contamination and displacement, perhaps permanently, of people from their homes and their livelihoods and their communities.
What you just heard was the Nuclear Regulatory Commission's chairman, Gregory Yasko, saying that the NRC doesn't take into account mass evacuations and people not getting back on their land for centuries when it does a cost-benefit analysis as to whether or not a nuclear plant should be licensed. I'm Arnie Gunderson from Fairwinds, and today I'm at the Regulatory Information Conference put on by the NRC in Washington, D.C. So today, I'm in Washington, D.C. A couple weeks ago, though, I was in Tokyo. And when I was in Tokyo, I took some samples. Now, I didn't look for the highest radiation spot. I just went around with 5 plastic bags, and when I found an area, I just scooped up some dirt and put it in the bag. One of those samples was from a crack in the side.